In this video, we'll be learning how to evaluate rational exponents, and specifically we're going to be focusing on fractional exponents because those we haven't practiced a whole lot. We focused mostly on integer exponents. Now we're going to look at what happens if we have a fractional exponent, and we're going to be able to do this with a calculator in some instances, but also without a calculator in other instances.
Now, before we dive in and talk about fractional exponents, we actually have to talk about roots because we use roots to kind of define and explain what a fractional exponent actually represents. So this first root right here should be a root we are all familiar with. So you should know that that is the square root of 9. By default, if there's no number in the root, you can just assume it is 2 because that is the most common of the roots. And what this right here is asking us is it's saying essentially what number, so I'm just going to use x hypothetically right here, what number to the power of 2 gives us 9. Now, because there is no symbol in front of this we can assume is going to be a positive number when squared that gives us 9. And so what number when squared gives us 9? We should, at this point, know that that number is 3. So if we have 3 squared, that equals 9, and as a result, the square root of 9 is 3. So now we're going to use that same type of logic as we kind of move down to these other examples down below. And all of these roots work the same way. This number right here is just going to update our exponent for each expression that we write. So for example, this 3 right here is telling us that this is the cubed root. And so what we're looking for is a number to the power of 3. Notice the 3 is no longer a 2 because of that 3 in the root. And this is saying what number to the power of 3 gives us 64. So you can kind of go through and do, okay, 1 times 1 times 1, that's equal to 1. 2 times 2 is 4, times another 2 is 8. Not what I'm looking for. 3 times 3 is 9, times another 3, that's 27. 4 times 4 is 16, times 4 again is 64. So what we found is that 4 to the power of 3 is equal to 64, and as a result, the cubed root of 64 is 4. Then if we kind of head down there to the 81, that one's going to work the same way, but now we're looking for what number to the power of 4 gives us 81. And so if we start to think through the different numbers, we find that 3 times 3 times 3 times 3, notice 3 to the power of 4 is equal to 81, and as a result, the fourth root of 81 would be 3. And then finally, from here down below, the 35, that's kind of extending in the same way there. Again, it's saying what number to the power of 5 is giving us 32. So we have a boatload of numbers we can cycle through, but in the end, it becomes 2 to the power of 5, or 2 times 2 times 2 times 2 times 2. And because 2 to the power of 5 is equal to 32, the fifth root of 32 is just equal to 2. So those are kind of our basics of roots. And what's really unique and interesting about roots is that they tie very nicely into fractional exponents. So to kind of show you how this turns into a fractional exponent, when we have a fractional exponent, the number inside of our root, which in this case is 9, becomes our base. And then you should know at this point that this 9 really has a power of 1 attached to it. We just don't write it because it's implied. But what happens here to create our fractional exponent is the exponent on our number inside the root, which in this case is 9, goes into our numerator. And then the number in our root here goes into our denominator. So the square root of 9 and 9 to the power of 1/2 are the same identical phrase. And this equals 3 as well. So you can flip between roots and fractional exponents pretty easily. Then if you look at this second one here, 64, again, there's an implied 1 here. This becomes 64 to the power of 1/3 because there's a 3 in the root here. That is the same thing as the cube root of 64, which is 4. And this same pattern just kind of transfers down. So here, This is 81 to the power of 1/4. Here, this is 32 to the power of 1/5. And so you can easily see how roots and fractional exponents, we can flip between them fairly easily. If you know your fractional exponent, you can flip it into a root and vice versa. So now let's dive in and try to solve a couple. So the instructions here ask us to rewrite the expressions below using a rational exponent and then to solve them. So this first one here, because this 16 has a power of 1, this would become 16 to the power of 1/4 as a rational exponent. Then from here, what we're trying to find is what number to the power of 4 gives us 16. Well, in this case, if I start thinking about it, okay, 1 times 1 times 1 times 1, that's 1. Then if I go 2 times 2, that's 4, times 2 is 8, times 2, that's 16. And as a result, I know that the fourth root of 16, or 16 to the power of 1/4, is equal to just plain 2. Now if I look at this next one, the negative looks like it might be tricky, but it's actually not. So this one is just saying what number to the power of 3 gives us negative 27. So here we're looking for what number to the power of 3 gives us negative 27. Now I know the only way to get a negative there is for it to be a negative number. And so I know it's not 1 because 1 is always producing 1, and I can kind of see from up here that it's probably not 2. So let's give 3 a try. So we know that we're looking to see if negative 3 times negative 3 times negative 3 is negative 27. Well, these first two multiplied give us 9. 9 times negative 3 is negative 27. So that is true. Our answer here is negative 3. And then we also need to be sure that we can write this as a rational exponent. Now, because there's a negative inside of the root here, I like to surround this with parentheses. Doing so ensures that that power that I'm creating goes all around that number that's in the root there. So I have negative 27 in parentheses to the power of 1/3. Now, looking at this third question here, I know this negative on the outside looks a little strange. All that means is you're going to take the result of the square root of 49 and you're going to multiply it by a negative 1. So if you have a negative on the outside, that's all it's implying. So this right here is saying what number when squared gives us 49. Remember, we need to write this as a fractional exponent. So this is going to be 49 to the power of 1/2. Remember, these two are interchangeable. We're looking for what number when squared gives us 49. That's going to be 7, and then we're going to multiply it by that negative 1 that was placed out in front. So our answer would be negative 7. And then finally, here on this last one, this one is asking us what number when squared gives us negative 36, which is a little bit confusing. Now, if we start off on this problem, we'll see that if we were to write this as a fractional exponent, again, because that negative's on the inside, I'm going to surround it with parentheses. So this is how we would represent it with a fractional exponent. And then from here, it's a little tricky to think through how to actually solve this, but we know that if we have a square root and we have a negative on the inside, that we can really rewrite that as the square root of negative 1 times the square root of 36. So we kind of got to remember our complex numbers here. We can't have a negative number inside of an even root. If we do, then that's telling us that we have something that, if it's a square root, is complex. So here we're going to end up with an I from that negative. The square root of 36 is 6. So our answer here would be 6i. So just being on the lookout for if we have negatives inside of a square root, that's going to produce one of our complex solutions, which is 6i.
Now, what's kind of cool about fractional exponents is that we can actually expand this a little bit more. We can expand this to cases where maybe the number on the inside has an exponent and we can actually solve them. So what we can do is we're going to first start by rewriting these as fractional exponents. So we're going to start by taking this root and rewriting it into a fractional exponent. It works in the same way it did before, it's just that our numerator now is no longer a 1, it's the exponent of the number on the inside. So here, this first one becomes 16 to the power of 3/4. Then here, this next one, because the negative 27 is negative, I'm going to use parentheses here, but this becomes negative 27 to the power of, we're putting 4 in the numerator, 4/3, so be careful with that. Number on the inside goes into the numerator. And then we have 64 to the power of 3/6. So again, number on the inside goes into the numerator. The root goes into your denominator. So that's where we start. Now what we can do is we can strategically kind of rewrite this here, because I don't know about you, but I'd rather solve the root first because I know that these numbers all work nicely with roots. So we can leave them like this, but we're going to rewrite them in this way. So notice that all I'm going to do is I'm going to essentially create my root, my 4th root of 16, and I'm just going to move that 3 to the outside. So here this becomes the 3rd root because the root is in the denominator. The 3rd root of negative 27, then take that to the power of 4. And then here I have 64, the 6th root of that, all raised to the power of 3.
So from here, I'm now going to start evaluating each of these. I'm going to start with the root that's just on the inside. So here, if I look at this example, it's saying the 4th root of 16. So I'm asking, okay, what number to the power of 4 gives us 16, just to start? And if I start thinking through my numbers, I know that the 4th root of 16 is 2, becomes 2 to the power of 4 is 16. So I can rewrite this part underlined in green as a 2. And then we take 2 to the power of 3 on the outside here. 2 to the power of 3 is 8. So we are able to evaluate the 4th root of 16 cubed, and by using our knowledge of fractional exponents and roots, actually rewrite it and find out that the answer to that is actually 8. Then if we kind of continue this thought process here, this next one here, we start by evaluating the root on the inside. What number to the power of 3 gives us this negative 27? Well, I know that that's going to be a negative 3, because negative 3 times negative 3 is 9, times another negative 3 is 27. And then I'm going to take that to the power of 4. Now, if I take negative 3 to the power of 4, I know that because it's an even power, it's going to be positive, because you go even, or you go negative, positive, negative, positive. And so I have negative 3 times negative 3 is positive 9, times another negative 3 is negative 27, times another negative 3 would give me 81. So again, I was able to take something up here that looked somewhat complicated and determine that it evaluates to be 81. Finally, this last one over here, I'm going to take the 6th root of 64. The 6th root of 64 is asking what number to the power of 6 gives us 64. That is going to be 2. So I then have 2 to the power of 3, which is going to be 8. So again, I took something more complicated and was able to actually solve it. Now, just as kind of a side note, if you were wondering here, could you have simplified this to be 64 to the power of 1/2? And would you have gotten the same answer? Yes, you also could have simplified that fractional exponent down to 1/2. And this would have just become the square root of 64, which is the 8 that we found. So we can use this knowledge of fractional exponents and their powers to actually now solve out some expressions that look a little more complicated.
So on this slide, we're going to discuss what we do when we have negative exponents. And all we need to do here when we have negative exponents is flip it to its reciprocal, and that will actually change the exponents to being positive, which is kind of a cool little trick to have in your back pocket. So here, if we turn this into its reciprocal, so here I'm going to move this into the denominator, and this becomes 1 over negative 8. We can't change the negative 8 because that's a negative base. But if we move the fractional exponent with its base into the denominator, that becomes a positive exponent. So if we just flip our negative exponents into the other side of the fraction, or we flip it to the reciprocal, it will become a positive exponent, and then we can evaluate it from here. So now we can rewrite this fractional exponent into a root. So this becomes the third root, -8, and then the power is just 1, so we don't need to write that. Well, what times itself 3 times gives me -8? Well, I know that that's -2. -2 times -2 is 4, times -2 again is -8. So this one is just 1 over -2. And then I don't have to apply a plus or minus because it's an odd root. So there would be my answer. Now this next one here, it looks a little weird. What I tend to do is I tend to start by applying this exponent to each number inside of here. So I have 1 to the power of -3/4 and 81 to the power of -3/4 because that's what those parentheses are really saying. And then from here, again, if we flip it to its reciprocal, so we change which side of the fraction those negative exponents are on, this becomes 81 to the power of a +3/4 over 1 to the power of a +3/4. So now I have positive exponents. Now I can just rewrite these as roots. I know that my denominator is my root, so this is the 4th root of 81, and then I'm going to put my 3 on the outside. And then I have the 4th root of 1
with my 3 on the outside. Now from here, we're now going to evaluate our roots. So if I take a look at my roots, the 4th root of 81, I know that what number to the power of 4 gives me 81? That is 3, because 3 times 3 times 3 times 3 is 81. So here I have 3 coming out of this root, and then to the power of 3. And then I'm thinking of what number to the power of 4 gives us 1? Well, the only thing that's going to give us 1 with an exponent is 1 itself, so that's going to be 1 to the power of 3 as well. And then I evaluate each of those. 3 to the power of 3, that's 27. 1 to the power of 3 is 1 times 1 times 1, which is 1. And as a result, my answer here is 27.
So there are going to be times when the number inside of the root can't be easily reached by just playing around with low integer numbers that we know. There is no number that we can think of off the top of our head that times itself 3 times gives us 13. So in those cases, we're going to be allowed to utilize our calculator to help us to find an answer. Now, in order to find our answer, depending on your calculator, there are a couple different keys you can use. The most common key you're going to use is called the caret key. If you look on your calculator, it's probably attached to the square root key or near the square root key somewhere on your calculator, and it'll look just like an upwards pointing arrow. So we're going to use that typically, but if you have a different calculator, these keys may be used. If you do, just ask for help and I can show you how to utilize those particular buttons. But this caret key right here is going to be the most popular key. Now, in order to use this, we're going to have to rewrite our roots into their rational or fractional exponent form. So this I know is 13 to the first power. I know the root goes into my denominator. So this becomes 13 to the power of 1/3. So I'm actually going to enter that into my calculator. What is very important here is the use of parentheses around your values, especially if you have a fractional exponent. So as we enter this into our calculator, we're going to enter in 13, the caret key, and then we need to utilize parentheses so that it follows our exponent all the way through the fraction. So we'll do 1 divided by 3. And if you press enter, you're going to see a very long decimal appear on your screen. Now, you don't need to write out the whole decimal. I'm going to ask you to round to 2 decimal places, which in this case becomes approximately 2.35, because the number after the 5 is a 1, and that will keep it at a 5 and not round it up. So for these next few pages, we're going to utilize our calculator to evaluate roots.
All right, so for each of these on the screen, we're going to rewrite the root as a fractional exponent, and then we'll use our calculators to solve. So to start by, I'm just going to start by rewriting all of them so they're in the correct form for my calculator. So this one, 3, is going to be my base, and my fractional exponent is going to be a 1/4. For this next one here, because the negative is inside of this root here, I'm going to put the negative 21 inside parentheses just to be safe. And then its exponent is going to be to the power of 1/3. Then from here, we have 52. Remember, if there's no number in the root, we can assume that that is a 2. So it's 52 to the power of 1/2. And then here we have 450 to the power of 1/6. So all we're going to do is plug these into our calculator directly and then round to 2 decimal places just to get an approximation for what these values are equal to. So if we plug 3 to the power of 1/4 in, we get 1.3160, etc. It keeps going on forever because it's irrational. We're going to round to 2 decimal places, so we got to look at the 1 and the number next to it. The 6 rounds it up, so we get 1.32. Then from here, we have a negative inside of here, so we're thinking about, okay, we have parentheses around that negative 21. We enter it into the power of 1/3, and if we round appropriately, we get 2.7, and then if you're looking at your calculator, you should see 7589. That 8 rounds it up to negative 2.76. Then if we look at the next ones, we enter in 52 to the power of 1/2. If we enter that into our calculators, we're going to get 7.21, and the number after that 1 is just a 1, so it doesn't round it up. And then finally for number 4, again, we just enter in 450 to the power of 1/6. And if we do that, we end up with a positive 2.7, and it's a 6, but the number after it is 8, so that's going to round it up to 2.77. So just kind of double check, can you enter them into your calculator and round them appropriately? So let's take a look at 3 more problems. So here again we see 3 examples of roots that we need to write into rational exponents so that we can plug them into our calculators and solve. So for this first one here, because the 5 is currently a power of the 3, that's going to stay in the numerator, and this becomes 3 to the power of 5 over our root, which is 4. So if we enter that into our calculator, again, we're going to be rounding to about 2 decimal places. So you're just going to enter that into your calculator as is, making sure that that 5/4 is surrounded by parentheses and in your exponent. And so if we enter that into our calculators, we're going to get 3.9482, etc. Again, we're rounding to 2 decimal places, so we take a look, 1, 2, and we look at the 8. This rounds the 4 up, so this is 3.95. If we take a look at the next one, we see that we have negative 21, so I'm going to put that in parentheses since it's inside of the root. Negative 21 to the power of 4 over 3, which in this case is going to produce 57.9 and then 3, but it rounds up because there's a 7 after it. And then finally, this last one here, remember there's an implied 2 in a root without a number, so this is 52 to the power of 5 over 2. And if we plug that into our device, we find that our answer is 19,498.82. The number after the 2 is a 1. It doesn't round it up. So that would be our answer. So you can plug these into your calculator directly. You can also keep in mind that you could break these up and do the root part first and then apply the exponent. It's really kind of flexible and up to you.